If you have companies like Lockheed Martin and others filing patent applications for coherent matter, and they're telling you, okay, it's going to allow us to cloak, we're going to have teleportation, we're going to be able to influence things at a distance, we're going to use this for directed energy weapons, and it's in this patent that the patent office takes 10 years to approve for Lockheed Martin. It's approved in March 2021, okay? Well, if they're getting patents in coherent matter, I guarantee you there's other life forms out there that already know how to do this, and they're using cloaking, they're using teleportation, and all the other sorts of really interesting quantum effects, I mean, that have an evolutionary advantage in survival with other life forms, other organisms, the ecosystem that you're a part of. Well, hey, I'm Simeon Hein, and I have a background in sociology. We're actually here at WSU, where I got my PhD many years ago. And, well, back then when I was in graduate school here, I was sort of interested more in conventional academic topics, but conventional with a twist. I was introduced to this concept here at WSU of fractal geometry, chaos theory, nonlinear math, which is another way of looking at how we interact with our environments, how things evolve over time. The traditional way to look at things in sociology, social science, lots of math, is to look for linear correlations, which is basically that things move in a sort of ordinary proportion, 1-to-1, and you're looking for linear relationships between variables of things that you're interested in studying. And sometime back, I don't know, 70s, 80s, 90s, there was this new set of ideas that became popularized as the butterfly effect. The butterfly effect is a butterfly flapping its wings over the Amazon rainforest can affect the weather of the entire world. If it's just at the right place at the right time, it can, a small change can cause a big effect. And that's chaos theory in a nutshell. And I was interested in applying those ideas to sociology to see if we could learn how we're changing over time as we have more technology, as we become more modern people. Is the level of complexity of our interaction with nature the same? Are we oversimplifying things? And so I started looking into those topics here as a sociologist back in the late 80s. What I was doing as a grad student, which had really never been done before in sociology, I was looking at something called fractal geometry. And this is important because fractal geometry is studying the shapes of nature. And we're used to dealing with very square and regular shaped objects from Euclidean geometry. Things are very regular, very even, and can be measured very easily. And this idea of fractal geometry, created by this mathematician that was working for IBM called Benoit Mandelbrot, was the idea that actually nature doesn't work according to straight lines. It works according to these fractured, broken up shapes that are self-similar at different levels. No matter what scale you look at them, you see the same sort of shape, but they don't resolve to a line because the closer and closer you look, the more detail you see. And that is actually the way things in nature look. And if you think of like your bronchial structure in the lungs, or tree limbs, how they're kind of branching and branching. So those branching structures are what fractal geometry looks like. It's another way to look at systems, not measuring it inch by inch in a linear way, but looking at the totality of the complexity of the whole thing and seeing if you can measure it that way. So that I was attempting to apply this into sociology, which was a new idea at the time. And that's really what I focused on while I was here, was can we look at the dimensions of a whole system and not just trying to measure it in a linear way as we were taught in social science, line by line by line, to get these linear measurements, which really may not be how reality works. We're trying to see if can you create a mathematical way of measuring things. That's the way reality actually works, versus your attempt to impose your ideas on the way you think it should look based on linear concepts. Okay, so that's what I did in the graduate school. So to get back to your question, and we'll link this all back in a moment. We're used to, just in the way that we're used to lines and very even things that we're attempting to measure with our very ordinary averages that we get from statistics and other mathematical concepts, basically trying to normalize everything. Just in that way that we're always trying to do that with reality, even if reality isn't working that way. It's more complex than that. We're used to basic phases of matter that we grew up with, that we're familiar with. Solids, liquids, and gases. And we're familiar with those because in our day-to-day experience, we perceive things that are either solid or liquid or gaseous, like the atmosphere. And we're also aware of other states of matter, like plasmas, which is the next state of matter past gases, which is ionized gases. And we see those in fluorescent light bulbs and in lightning and in lots of plasmas out in the galaxies. And actually, plasmas are the most common state of matter in the universe, are these ionized gases which glow, and they're warm, and they can often give off a lot of heat. And again, we're most familiar with those in fluorescent light bulbs of various forms, which we're all, we have in our homes and so forth. But there's a fifth state of matter beyond plasmas, and that's when the matter gives up its individual identity and becomes a quantum coherent structure. And all the particles now are at the same temperature and the same frequency. When they do this, they can change states and do things that ordinary matter can't. For instance, the ordinary matter that we're used to just can't become invisible like that at a flick of your finger. The chair is not going to disappear. But coherent matter can work in ways that ordinary matter can't because it's based on quantum principles. So it can easily go into what's called a cloaked mode. It can go into what they call a dark plasma mode, where you don't see it anymore. It could still be around you, but you can only detect it with infrared equipment. So because of the way we perceive reality, we're used to states of matter that we can easily relate to, that we can touch and we can see and we can hear and we can feel. But there's states of matter beyond these ordinary states that we're used to, coherent matter being one of them, another type of matter, that can work in ways that we're not used to, so we're not even capable of perceiving it a lot of the time. And the reason we know this is true is because people who've worked in the CIA have come forward to talk about this. They monitor the U.S. for all sorts of different events. We know the Department of Defense monitors the U.S. for strange electromagnetic signatures, which would be indicative possibly of terrorist attacks or atomic weapons or things like this going off that they want to monitor and to protect the United States. So normally you don't have the Department of Defense working within the United States, but we know from James Lukatsky, his book Skinwalkers at the Pentagon. Okay, so we know that, and John Ramirez, who's been talking a lot about this recently on different podcasts and YouTube channels, who said he's been given permission to talk about all of this. They monitor the U.S. for all sorts of abnormal, out-of-the-ordinary types of matter and energetic properties that would maybe indicate that there's been some sort of attack on the U.S. or something that gives them an indication that something's off. So through their satellite systems, they can detect all sorts of types of matter that you and I normally can't see. And this includes the coherent matter. they can see it coming into the atmosphere. Of course, this gets into the topic of UFOs, UAPs. But for our purposes, what's important is that these states of matter are not visible to the naked eye, but they can be seen with satellites that are looking for infrared. And what they call these are orbs. They actually call them orbs. And they say that they enter the atmosphere from outside the Earth, and they seem to be under intelligent control. So that's a type of matter where it's beyond our ordinary sensory ability for you and I to see, but with the special equipment, you can pick it up, you can detect it. But it doesn't really end there. That's really just the beginning, because if you do have these other states of matter that these different agencies look at to, just in sort of the defense of the U.S., that they feel it's in their job description to be analyzing the electromagnetic spectrum, you sort of have to wonder whether there's other types of life out there that's already, using those states of matter, that's sort of interacting with those states of matter, maybe even based in those states of matter, that's already indigenous to the Earth. And that's how you kind of get into this discussion of dark matter relic neutrinos. The relic neutrinos are something that's really interesting that we've only learned about recently. Those are the original radiation from the cosmic background from the time of the Big Bang. These are particles that decoupled from the rest of the universe, we're told, 1 second after the Big Bang. And they're still radiating down on the Earth because they're coming from the far edges of the cosmos. And why relic neutrinos matter to us is they have a wavelength that is much bigger than solar neutrinos. We've all heard of these solar neutrinos, and we were talking earlier about those experiments that they have in Japan, these neutrino detectors and so forth. Okay, those experiments, they have some, I believe, in South Dakota too. There's a couple experiments around the Earth that look to detect these neutrinos. Now, they're very hard to detect because they're so small, they don't interact with anything. And they can go for a couple light years in lead without even hitting anything. So they're seeing if they can detect them. They're emitted by the sun, but they're so small and they're so fast, for the most part, they're irrelevant to us because they don't interact with anything. And again, if you don't think there are things that are invisible out there, we know solar neutrinos are invisible. It's almost impossible to detect them. They don't interact with anything. We know they're there. And these experiments that have been set up with special types of water and so forth, they get a couple pings. They get a couple detections of these like per year, if they're lucky. These events are so rare to detect solar neutrinos. But that's not the type we're talking about that matter to us here. The relic neutrinos, they call them relic because they're from the original Big Bang, and they're from the cosmic background radiation. Relic neutrinos, again, are really tiny and have a very small energetic potential. It's really tiny. But they can be detected gravitationally, and different scientists have found ways to detect the relic neutrinos. But the reason they matter to us is their wavelength is big enough to interact with cells and biology and subatomic components too, all the way up from the subatomic to cells. The wavelength is, I think, 3 to 4 microns or something like that. It's pretty large for a particle. So that means we're interacting all the time with energy that's coming from space that's invisible but has a slight energetic effect, and scientists generally agree it's a small component of what we call dark matter. Now, the reason that dark matter is so important is all of these models of cosmology that we have, the so-called double dark model, is dark energy and dark matter, which is highly accurate, and it's extremely consistent with all the observations from space. These models say that there has to be another type of matter out there that we can't interact with directly, but we interact with gravitationally, and that there's something like 10 particles of dark matter for every particle of regular matter that we see. So if you look around the room, you look around the earth, you look around the universe, you think you see what's going on, there's 10 times as much matter that you don't see doing its own thing that you can't even detect, but all the models from the way that galaxies rotate and so forth say this has to be there. And it's not just this century. People were talking about it hundreds of years ago, that there has to be some sort of a dark material to explain how the universe is able to hold together, why it doesn't fly apart. Because there's not enough mass from physical matter to create enough gravity to hold everything together. So, people have speculated about this, and just like they did with black holes, sometimes it takes a long time to actually get evidence of black holes. And just a couple of weeks ago, as of this filming, there were some photos of black holes. I think it's the second one, right? And those are colorized, by the way, so that they look like something we can recognize, but they can actually take a picture of something like this. Well, it's kind of the same way with dark matter. A lot of people say, where is it? Where's the proof? Well, sometimes, as our friend Albert Einstein said, imagination is more important than knowledge. You almost have to see it in the model. You have to look at all the data, and it's telling you it has to be there. So, relic neutrinos are a small percentage of dark matter, based on all the evidence that we have. And I've gotten into discussions with people recently about this, but if you look at the work from the CERN theory working group in Switzerland, with their CERN super collider, and NASA and other, authorities in space sciences, they tell us that these relic neutrinos are there. Now, a small percent sounds like a very little bit of dark matter, but it's actually more than all the mass of all the stars and physical material in the universe, even at a few percent of dark matter, because dark matter, so much of the universe is dark matter, not to mention dark energy, which is even more. So a small percentage of dark matter being relic neutrinos is pretty huge. That means that we're interacting with something all the time. It's probably absolutely critical to life, to biological life, to have this energy source from relic neutrinos. And there's actually more to it than that, because we emit the same wavelengths, again, from our body, from biological interactions. This has been referred to as chi energy. Maybe you've seen examples of psychokinesis, where people can move things around with their minds, with their body, without physically touching an object. I've seen demonstrations of this in Japan. It was something that was initially hard to believe, but seeing what this individual is capable of doing, I have no doubt he was actually literally melting glass in his hand. Not just spoons, but glass, levitating his objects. In fact, from the distance where we are right here, I saw him. He was levitating a cigarette over his palm. And in my mind, I'm thinking, okay, there's got to be a string there. I'm a grad student of this university. I'm thinking it's got to be a rational explanation. The things don't just float, but it was floating. And the way I know it's floating is because he must have seen my doubt or something, this practitioner, near this area north of Nagasaki. I was teaching remote viewing there, and one of the students said, you got to go see this guy. So, Dr. Anderson, I think, Mr. Anderson, as he called himself. That cigarette, he looked at me. That cigarette went flying off over his hand into my shirt pocket and came in with force. As it approached my shirt, it made a 90-degree angle and went into a pocket just like this. I still have the cigarette. I thought, there had to be magnets in this. There were no magnets in that cigarette. I've looked at that cigarette. I'll show you the cigarette someday. This was an ordinary cigarette. It's levitating above his palm. He was doing this with yen notes. And when you're at a distance from somebody, you're thinking, modern people like us, you're thinking, is there a trick here? Is this a magic trick? You don't know, because magic can look often like a paranormal phenomenon. There's a gray area there where you can't quite tell the difference. In science, we call it mixed mediumship. There are people that actually do real, accomplished feats of psychic prowess, who actually do something psychic, but they also do magic, because sometimes they have off days, and so they they do a magic trick because they want it to look good in front of the camera. But that doesn't mean at other times they actually aren't doing the real thing. And it's called mixed mediumship. There's a real name for it. And I've heard many lectures about this at conferences, why people do mixed mediumship. So I'm thinking, is this mixed mediumship? What is this? No, that cigarette flew off of his palm, just like he just looks at me and just comes in, goes into my shirt pocket. Now, I could spend all day throwing cigarettes at you, trying to get it into one of your shirt pockets, and I might not succeed. He did it on the first try. So I've seen examples of psychokinesis. Apparently, what psychokinesis is created by our ability to generate cold neutrinos, which is the same thing as the relic neutrinos. It's just coming from a biological organism, not from the outer reaches of space, from the cosmic background. So there are these other types of particles and energies which physics is becoming more familiar with. This whole discussion of relic neutrinos, I mean, this is something that's happening right now. This isn't like settled science from 100 years ago. Because, for instance, we were talking earlier about Dr. Alexander Parkhomov in Russia, that book, Space, Earth, Human. He set up a relic neutrino detector based on, surplus Soviet equipment, which, it would have been hard to get after the Soviet Union fell apart in 91, 92. And this is a guy from one of the top classified aeronautics institutes in the previous Soviet Union, one of their top nuclear scientists. He created a relic neutrino detector, and he could detect changes in how these relic neutrinos come in from the universe based on the time of day, where the Earth is positioned to the solar system, and more importantly, where the Earth is in position to the Milky Way. Because as a component of dark matter, it's lensed gravitationally around large objects like galaxies and planets and our sun. So he was able to show that our position related to the sun or the moon would affect his measurements of the relic neutrinos, which would be really consistent with what you'd expect if these things are affected by gravity. They're coming in from the outer reaches of space. And they affect things that matter to us. They affect nuclear decay rates. Normally, when you have atomic decay, it should be like, it's random, but the average should be the same day in, day out over all the different experiments that you're doing. There shouldn't be any variation. But he was able to detect variation based on the position of the moon, position of the sun, variation in decay rates at an atomic level, changes in plant growth, and other phenomena like that based on position of the sun and the moon, which would indicate that these particles, as they're coming in, would sort of be in a different position, would change their behavior and the amounts of them coming in because they're affected by large gravitational objects like the sun. So to even have another type of cosmic energy coming in that we can measure now that interacts with us, with biology, they also found it with chemical reactions too, that there is a correlation between these relic neutrinos and chemical reactions. Well, the reason this all matters is because this gives us a particle that can drive cold fusion reactions. And initially, when we heard about cold fusion from Fleischmann and Pons in '89, the theory was not developed enough. There were people working on it. It goes back quite a ways, but we didn't hear about it. The theory was not quite developed of what actually was happening in these, fusion reactions. Was it actually neutrons fusing with each other like you'd get in hot fusion, but in a cold tabletop experiment? What exactly is going on? Based on all of the measurements of relic neutrinos and the math and so forth, it shows that these relic neutrinos can drive something that's called inverse beta decay. And it's one of the things that you look for in a fusion reaction. And the neutrino has enough energy to drive this inverse beta decay, which would create what we call cold fusion reaction. Now it's called low energy nuclear reaction. And it seems quite likely to me that if we can do this in laboratory experiments, there have to be life forms out there that are already doing this, that are absorbing these neutrinos, creating their own type of inverse beta decay, or using this energy in some way. And the reason you would expect that, it's very simple. Nature doesn't waste anything. We know from every single thing we've ever looked at that nature doesn't waste any energy. It doesn't waste any, it recycles everything that it can, in our bodies, in any biological system for maximum efficiency, right? If there's another type of energy source out there that we can measure in cold fusion laboratory experiments, and obviously just having this conversation with you right now, I'm arguing that cold fusion is real. I know that could even be controversial, but we just have too many decades of evidence now with experiments that match up showing us that these reactions are real. Why it's not easy to sustain, into something that we could all power our homes or our cars, that's a whole nother discussion because it's quite a challenging reaction to control. But that doesn't mean it doesn't happen for a while. And it can be sustained for a while. It's a very sort of finicky reaction to use as a reliable power source. But that's a whole nother discussion. And maybe people have done it, maybe they haven't. But the process itself, we know, it exists. And it has to be that nature is already using this. If we're just figuring this out now technologically from lab experiments that have been going on for the last 50, 100 years, it goes back quite a ways, then it's highly likely that there are life forms out there right now that are already using this and getting all of the benefits of coherent matter that our own defense contractors are filing patent applications for. I mean, if you have companies like Lockheed Martin and others filing patent applications for coherent matter, and they're telling you, okay, it's going to allow us to cloak, we're going to have teleportation, we're going to be able to influence things at a distance, we're going to use this for directed energy weapons, and it's in this patent that the patent office takes 10 years to approve for Lockheed Martin. It's approved in March 2021, okay? Well, if they're getting patents in coherent matter, I guarantee you there's other life forms out there that already know how to do this, and they're using cloaking, they're using teleportation, and all the other sorts of really interesting quantum effects, I mean, that have an evolutionary advantage in survival with other life forms, other organisms, the ecosystem that you're a part of. There isn't a single thing that humans don't use that they have for some sort of advantage when we get it, right? And we're always, any of us, we're always up against energy constraints, the price of energy, so forth. People, nation states, companies have to deal with paying for energy. It's expensive. If you could immediately get some sort of energetic advantage that was already sort of built into the way nature works, and it allowed you to create other states of matter, I mean, over the course of evolution, creatures and animals would be using this. And by the time it got to where we are now, they might not even be recognizable as ordinary types of matter that we're used to because they've evolved. They've evolved past where we're at. And that's, that's a really big thing to admit that we're not top of the food chain. I mean, we like to think we're just the pinnacle of creation, right? We're the bee's knees. That's what humans are, right? The cat's meow. We're just the best at everything. But let's say it's not true. I mean, let's say we're not the most evolved thing on the planet. So that's where this. So, Jill, that's where this all comes down to. Is if you have these other quantum processes going on, and we're discovering them, defense contractors are getting patents in them, and so forth. On one hand, they've been telling us, "Oh, cold fusion, that's not real. That's a fantasy. It's junk science." But we want a patent in it. You can't have it both ways. You're publicly saying, okay, this is not real. This is junk science, pathological science. We're going to fire these guys who invented cold fusion. But by the way, we want our patent in it. Come on, give me a break. So I think we can see what's going on here. There's a level of science, maybe it's classified, maybe it's not, that has to do with creating other states of matter. And then there's the possibility that life has already found out a way to do this right here on Earth. And it's using all of those things that you can read in the Lockheed Martin patent application: cloaking, teleportation, some sort of morphine into shapes. That's what that patent lists the whole thing. And so I just think that's a logical way to look at it. And so that's how, I don't know if that answers your questions about the relic neutrinos and the coherent matter, but there's a link between all these areas of science. People have been studying it. And, it's real. It's real. Fusion energy is what happens when you have hydrogen fusing into helium. The neutrons actually fuse, And we're told this is how the sun works. This could be part of the explanation. It's how atomic weapons work. It creates a lot of energy. Fusion, hydrogen bombs work this way. It's where subatomic particles fuse together under high degrees of pressure. And when they do that, they release a lot of energy and a lot of heat. And so there's been an attempt within the physics community to create these hot fusion projects. And you've probably heard of these before. This is an attempt to recreate what's going on in the sun in a laboratory experiment, so you can generate the energy that we get from the sun in a controlled way without any radioactivity like you would get with fission. We're all familiar with fission and nuclear weapons that are based on fission. Atomic bombs were dropped on Japan, and ever since the Cold War, there's been a huge buildup of different types of atomic weapons. Fission is one way where the nucleus comes apart from the atom, but the other alternative is where you have fusion, where you can push them together. And this is how the sun works. So there's been attempts to create this with so-called hot fusion reactors. Now, these are really expensive. They cost billions and billions of dollars. And so far, they've been able to reproduce. They're very complex, by the way. They require intense magnetic fields to create that sort of compression. And they can't be sustained very long. The record, about a year ago, the record of fusion reactors, which, there's some of these different countries, these fusion reactors, they're called tokamaks. The record was 1/trillionth of a second for sustaining a fusion reaction, where you're pushing matter together and it fuses hydrogen into helium and creates a lot of energy when you do that. I think I read a few months ago they had the reaction now maybe to a second or so, really short. Now, so here's the funny thing about fusion. Ever since I was a kid, we were always told that hot fusion was only about a decade away. And I remember hearing this in the 70s. You guys heard it too once, you were old enough to understand something like this. Just about a decade away, we would have unlimited, cheap, clean energy from fusion reactions, which would recreate what goes on in the sun in a contained vessel, which would be safe and inexpensive. It doesn't produce radioactivity like fission does, right? And we all know the dangers of fission reactors, because our nuclear reactors that create power this way, if they have a problem, they can be dangerous. If you have subs that, anything that's powered this way that has an accident, you could release radioactivity. But fusion doesn't release radioactivity because it's not fissioning things apart, it's pushing things together. Okay, so that's hot fusion. Now, the joke is within the fusion community that the Russians gave the West the tokamak reactor. And this is a really interesting, if you look at it, it looks like a Theodore Geiger painting on the inside of a tokamak. It's all these twisted torus-like shapes to try to create a magnetic field that's going to contain this reaction. Why? Because it's really, really hot. It's like, I don't know how many millions and billions of degrees a fusion reaction is, but it's going to completely annihilate anything it comes in contact with, because it's burning at the temperature of the sun. Not the surface of the sun, but the corona, like millions and millions of degrees. So you try to create this magnetic field that's going to contain your reaction. And the joke is that the Russians gave the West these tokamak reactors so that they would just waste billions and billions of dollars on something that was never going to work. Because the way nature does it with cold fusion reactors is it creates its own natural magnetic confinement system at a small scale. And that pressure, that nucleonic pressure, creates the cold fusion reaction. At least this is our best understanding of how it works at the moment. And this is from the work of Takeaki Matsumoto in Japan, who worked on this since the 90s. He was able to reproduce Fleischmann and Pons. He realized it was a type of gravitational decay and a type of pressure that would push these particles together. And the electron clusters would kind of get closer and closer and really create this really incredible pressure, which would create a natural type of fusion reaction. So this is the way nature would do it. It creates the fusion, not with really complex technology on the outside that costs billions and billions of dollars. It's just a natural function of how charge clusters, once they come together, create a really strong, attractive force that pushes all the atomic material together. Matsumoto called it an itonic cluster. He had his own name for it. And the reason we didn't hear about him is he was banned from publishing in Fusion Technology and Science magazine from the American Nuclear Society once he mentioned ball lightning. I think it was 1993 or so. They wouldn't let him publish anymore because he mentioned ball lightning. He claimed that this ball lightning was actually a fusion reaction. In fact, Matsumoto was the one that, I think in a brilliant way, said that cold fusion and ball lightning are the same thing. And that is not much different than our friend Einstein saying energy is the same as mass, E equals mc squared. I mean, that's what science does, is you say, look, these things look different, but wow, if we actually look at it, they're the same thing from looking at it from different points of view. Energy and matter are the same thing, mass times c squared equals energy. That led to the whole nuclear age that we live in now. And it was our friend Einstein who, figured that out with his general theory of relativity. So Matsumoto actually realized that cold fusion was actually tiny ball lightning. That it was actually the same phenomena, which, it's kind of astounding. And then he went even farther. He said that black holes and neutron stars and ball lightning and cold fusion are all the same thing, which actually makes sense, that neutron stars and black holes are a type of compression, and that when it happens on Earth, you get mini ball lightnings. And this guy is not a theoretician. He discovered this from frickin' experiments, painstaking observations. If you look at his journal articles, I've read these many times, they're fascinating. He shows you the picture of the tiny microscopic black holes in his cold fusion experiments, little areas where there's no light coming out. And then he also shows other areas where you have the mini ball lightning, what he called micro ball lightning. So what we're talking about here is a grand unification of science at a huge scale. This is no different than what Einstein did. Absolutely no different. Or any science, every couple hundred years you get this unification. It's like what Copernicus did with the Ptolemaic point of view, which is basically you don't have all these planets doing their own things and having different orbits around each other, very, very complex orbits that mathematically they worked to predict where Saturn or Jupiter or Mercury would be. Because when we look out at the sky, you see them kind of retrograde motion, and they couldn't explain this retrograde motion 500 years ago. They thought, are they going backwards? And they did. They thought they're going backwards for a little while. We now know it has to do with parallax, and where our point of view is, where we are in the solar system, things appear to go backwards temporarily, but they're not going backwards. They're orbiting around the sun, but it looks that way, right? Well, what Matsumoto was able to do is say, these aren't all different phenomena. It's not all that. This is all the same thing. It's electrogravitational collapse. It's a type of gravitational collapse caused by electromagnetic energy, in that when you put clusters of charged particles together, and you go beyond a certain distance where they repulse each other. We were all taught this in school, that electrons repulse. Similar charges repulse, and we did experiments in high school physics classes that showed put things of similar charge together, they repulse. But what people in this community are able to show since the 80s is, and probably before that, if you put charged clusters really, really close together and you keep pushing them together, you need enough energy to do this. All of a sudden, they'll start really attracting. They'll attract in the strongest way, and they'll actually start collapsing matter, creating literally gravitational decay. Gravitational decay. The nucleus of these atoms will collapse, and it'll hold everything in, and then it'll disappear. And that's what a cold fusion reaction is. It's just a temporary mini black hole that you get at a subatomic level. And that's how, so the fascinating thing about this is you can connect all these topics from black holes out there to neutron stars. Everyone accepts neutron stars. These are stars that are starting to collapse. And as the collapse keeps going and going, you get other states of matter. You actually end up with alchemy. This is how you get nuclear transmutation, because the pressures are so strong from what Matsumoto called the atonic charge clusters, the atonic matter. The pressures are so strong that it literally transmutes matter. And Matsumoto was able to show that in completely pure lead balls, in these cold fusion experiments, you would have carbon film erupting out of them like a volcano. He has this from a scanning electron microscope. Literal elements where you tested them before, 100% pure lead, all of a sudden you've got carbon spewing out, carbon films, carbon sprays. No way you could get that from a chemical reaction. That has to be some sort of fusion reaction going on there at a subatomic level that science told us it was impossible. Well, if it's impossible, how are you getting carbon film coming out of a lead ball? And this happens with tungsten and iridium and all sorts of other elements where they're 100% pure, and then you initiate the cold fusion reaction, and all of a sudden you have other elements there a couple hours later, a couple days later, that were not there in the original sample. That can only be alchemy. I was taught that alchemy was some sort of medieval fiction. Even Isaac Newton was interested in alchemy, right? I mean, he spent part of his time working on gravity, and he spent another part of his time trying to prove that his laws of motion explained the Bible. And then another part of his time was spent on alchemy. He was considered the great alchemist at the time. And yet we were all told that that was fiction. There's no philosopher's stone. You can't turn lead into gold. You can. These experiments have shown you can produce every element in the periodic table with the right sort of experiment. That's what Matsumoto found. This is what Ken Shoulders found. And if you listen to the interviews of Martin Fleischmann from Fleischmann and Pons at the University of Utah in the late 1980s, he was talking about this too. And he was talking about the anti-gravitic effects of cold fusion. And I think you can see why this is classified now, because it creates anti-gravity. And that is like, one of the highest, most highly classified subjects that you could have within the military. It's no surprise that the U.S. Air Force funded all of these experiments initially, going back to Winston Bostick in the 1950s. They were funding these fusion research. Winston Bostick, since you asked about fusion, he was looking for peaceful uses of fusion energy. They wanted to turn it, from something that had been weaponized and had been used against Japan in World War II. Could you de-weaponize it and turn it into a peaceful energy source? So the Department of Energy funded Winston Bostick, who was at Stevens Institute of Technology, and then in the University of California system in the 50s. But if you look at his papers, it always says funded by the U.S. Air Force, funded by the Department of Energy. And it's no wonder that some of these ball lightning studies from the Air Force are so heavily redacted. The one done by Eric Davis in 2003, you can find it. Almost half of it is completely whited out, and it's ball lightning, natural ball lightning. Why would that be classified? Because there's an anti-gravity effect. So ball lightning is something that's been of interest, for a long time to humanity. It's been seen for hundreds and thousands of years, and it's been seen in natural circumstances. It's seen around thunderstorms. It's seen in particular locations like Hessdalen, Norway, where there are particular mineral elements in the soil. But it's also been seen around earthquakes. And the reason you get ball lightning around earthquakes is all those tremendous pressures from the tectonic plates moving around causes that type of pressure, which pushes charge clusters together, which we're talking about a few moments ago, pushes the charge clusters together and pushes them enough that they become a form of coherent matter. And Matsumoto noticed this because there were earthquakes in Japan while he was doing his research, and you would get these ball lightning. He would call them ball lightnings, which is kind of funny. But you would get this ball lightning around earthquakes. And, these have been seen all over the planet, right? They're sometimes called earth lights. And we've often seen, I remember hearing a lecture about this at one of the scientific conferences, Society for Scientific Exploration. And the woman that presented this, Marcia, showed how you get ball lightning before earthquakes. She was actually thinking of using it as a way to detect earthquakes a couple days ahead of earthquakes. You would find ball lightning. Sometimes, though, you would only see it through infrared photography. You would see at the top of mountains these glowing plasmas, which John Ramirez referred to in his interviews as the orbs. You would see them at the tops of mountains sort of sitting there. And I think this was researched by NASA. They would find that this was, before an earthquake, you would get ball lightning, orbs, and various anomalous light phenomena. So the ball lightning is a 100% natural phenomena, but you can also create it in the lab. Nikola Tesla would create it in his energy experiments. He would get these ball lightnings showing up. Sometimes it would cause these power failures in the transformers where he was operating. I think it happened in New York City. I think it happened in Colorado Springs. He blew out some transformers. So he would get these in his experiments. But people have reproduced it recently in their experiments. I mean, we're talking about small ball lightning, just floating around a plasma discharge tube or something like that. So the argument here from Matsumoto and others, this is all the same phenomena. And believe me, this is contentious. Looking at the literature of ball lightning, and I've become fascinated by the subject. So I'm just reading all these books about ball lightning going back 10, 20, 50 years. People have been studying this ball lightning for over 100 years. There was a guy named Walter Brand that had a book about it in 1923 in Germany. And all of these researchers collect, anecdotal evidence from witnesses. They'll have 50 accounts, 100 accounts. It's really fascinating to read the features of this ball lightning, because it's such a weird thing to be around. Most of the time it's benign, but it can also be deadly. Sometimes it just shows up. You've probably read reports of this entering airplanes and going down the aisle. You've seen this, because it can be associated with thunderstorms, with regular lightning. But it shows up around earthquakes, like you're asking about. It shows up around earthquakes. It shows up anytime you get compression of matter. You're going to end up with charge clusters coming together, and those charge clusters are going to form ball lightning at some point if the conditions are right. Now, this is exactly why cold fusion was so hard to reproduce. It doesn't take place on the surface. It takes place in the cracks, because in the cracks, if you have hydrogen gas and something like palladium metal, you have to have the right cracks for the hydrogen to get in there. It starts getting compressed, and it turns into the ball lightning and the charge clusters and gets a cold fusion reaction going. But all the researchers that started looking at this since Fleischmann and Pons, they were doing it with pure palladium that didn't have any cracks in it. And Vittorio Violante from ENEA in Italy, the leading Italian energy research institute in Italy, told us this at a meeting in 2015 in San Francisco, Society for Scientific Exploration, the San Francisco meeting 2015. He said they had attempted to reproduce cold fusion, and they did. They said it could take up to 100 days to get the reaction going. It's that finicky. But once it was going, they were getting excess energy that was not coming from any chemical means, right? And he said the researchers that initially studied this, like MIT and all the ones that George Bush formed this cold fusion panel to investigate this, they were using pure palladium, which doesn't have the right grain size and the cracks for the charge clusters to form, because there's no pressure if it's smooth. It doesn't happen on the surface, it happens in the cracks. So it took all these researchers a while to figure this out. But of course, back in 89, 90, when they were saying, okay, we're going to test if Fleischmann and Pons are, if this is a real effect, they were using the wrong materials and they didn't have enough patience. I mean, 100 days is like a long time to wait for this. But here's the cool thing about it. Once you get the reaction going, it can sustain itself for 2 days or even up to 2 months. I'm talking about a little ball lightning living in metal months after you turned off the energy going into it. It's just persisting in metal, waiting for a moment to come out of there. That means we could have charge clusters around that are buried in surfaces right now. You wouldn't even see them, and they're just waiting there. And they could pop out at any time. And this is what they found in the Russian experiments and in other experiments, is you would turn the whole experiment off, take all the wires out, and this ball lightning is still living in there in subsurface for days or weeks or months, glowing, literally glowing. They're doing its transmutation. It almost seems like a living object. And again, I don't know of a single thing in nature that life doesn't use. If these exist, there are things out there that are already using them that are taking advantage of whatever benefits you get from having that type of energy source around, or interacting with it in ways that we don't understand yet. And that would allow them to do some really interesting things. We normally don't think of life as being invisible. You don't think that there are invisible life forms out there. But if this is correct, these charge clusters can become ball lightning, can sustain themselves, can roll around. People have seen them, and they do all sorts of things. And then they can go into a dark mode where they're still there, but you don't see it. And I think this is what people see at Skinwalker Ranch. It's not the total explanation for what's going on at Skinwalker Ranch. But here's the thing about it that's really interesting. It seems like a living thing when you're around ball lightning. It's so sensitive to electrostatic gradients. It floats right above a floor surface because that's exactly the electrostatic gradient it wants to be at. That's why it goes down the aisle of an airplane between the seats. It's sensing the electrostatic energy, and it's going right down. It can follow you around, and you feel like something is following you around. There are these cases on Skinwalker Ranch, remember, where you had these, the blue orb came in, and those dogs, Terry Sherman, I guess it's okay to say his name. They refer to him as Gorman in The Hunt for the Skinwalker Ranch, but his name was Sherman. And he said it, this blue orb came out, and the dogs are barking at it, and they're snapping at it, it's going back, it's going forward. And the dogs chase it into the woods, and he hears these yelping sounds, and the next morning he goes out, and they've all been reduced to puddles of fat. It's very tempting to think that that's an entity deliberately killing those dogs. But the other explanation you have to, if you're a reasonable person, you have to look at is that ball lightning is really sensitive to anything that's around it. It's going to be moving forward. It's going to be moving back. It could look like a lifelike thing. I could be wrong about this, but this is what people have been reporting for hundreds of years. And when ball lightning comes apart, it can be lethal. It can fry things. It can fry electronics, like you see at Skinwalker Ranch happening all the time, and we've seen around crop circles. It can kill things from the energy that's being released as it comes apart, because all the matter is coming back to a normal form, and it's just sucking energy out to reconstitute itself as ordinary matter. And it can release a ton of electricity at the moment it comes apart. And we've seen this in cameras and batteries around crop circles. But this is what people have seen around Skinwalker Ranch, and there are reports of farm animals being killed by ball lightning going back 100 years. So the reason I'm saying this is not totally new. It may be new for the researchers at Skinwalker Ranch, but it's not new in the history of ball lightning research. All you have to do is read any of these works of ball lightning by Stanley Singer or other. There's a Russian researcher named Bichkov who had this whole thing in a book about the atmosphere and the ionosphere. That's what it's called, the atmosphere and the ionosphere. There's a whole long chapter on ball lightning at the end. He goes into all the historical research. It follows people around. It can disappear. It can explode and knock down walls of buildings. So the real point of this is that ordinary matter that we're used to can take non-ordinary states and do really strange things, destructive things that we're not used to. That doesn't necessarily mean that it's an entity with intention to hurt. It's just the way lightning can come down and people can get hurt by regular lightning. It's not the intention of the lightning to do that. You just happen to be in the wrong place at the wrong time. There are areas on the Earth, you could call them portal areas, others that have high concentrations of minerals that make it a lot easier for this ball lightning Earth lights to form. Assuming that they're all sort of the same, they have the same source, which is coherent matter. There is some discussion about this debate. Hessdal in Norway is another place where, there are a lot of really interesting lights seen. You could see those as UFOs, but the reason that we think that has something to do with ball lightning is you find these crenulated iron spheres in the soil, exactly the same way you do in a cold fusion experiment. You find these spheres, and they have these really interesting surfaces that look kind of like, we call them crenulated because it's weaving this way and that way. It's a very interesting surface to look at, very complex. Those have been found at Hessdal in Norway, and they're found in cold fusion experiments. John Hutchison, the Canadian inventor, was able to create all of this by reproducing Nikola Tesla's laboratory equipment, right? And he was someone that's very controversial. Is this fraud? Look, what he did is exactly what Tesla did. He followed the instructions. He just had a really good mind for this sort of stuff. I used to build electronic equipment as a kid. I never did anything like close to what John Hutchison did. He was able to melt metal at room temperature, not at high temperatures like from a welding torch or something. We're talking about room temperature. He has, you can see images where coins were melted into the metal at room temperature because we're talking about nuclear transmutation. It's a type of matter changing into a coherent form and then back into regular matter. In that moment that it's incoherent, regular objects can like blend into other objects. Well, if you look at the phenomena that people out in the field have reported around Bigfoot, from Ron Moorhead in the Sierras, the Sierra Sounds, the people that have really researched this, I'm not talking about the academic people. I'm talking about the people who've been out there in the fields with the Bigfoot and whatever else is out there. What they report experiencing and sensing is very similar to what people report who experiment with coherent matter. There's some of the same phenomena going on. And I think it's really reasonable just to suggest that these could be overlapping phenomena because, all of these phenomena that we call paranormal, there are some underlying symptoms here that we always see: sudden temperature changes, kind of strange smells, strange effects on equipment, batteries, cameras going out, electronic equipment acting in really strange ways. Now, this is something I've seen since the crop circle, since the film crews that I filmed with, National Geographic and others told me they had experienced this with their cameras being around crop circles. They told me the BBC crews came out and had their cameras whacked so badly they actually had to call back into London for instructions how to reboot their cameras, something they'd never done, from scratch. This is how badly they're fried and affected electronically. So when you hear this happening around cryptid encounters, you could say, look, it's a totally different phenomena. That's why people's batteries and cameras are going out. And that's possible. We could be dealing with something so different that we don't even have a grasp of what it is. But I think the other position is also something that you need to look at, that this could be similar phenomena, and that the reason you get some of these strange electronic effects, strange effects in people's sense of space-time, the weird feelings that people have around Bigfoot and other cryptids. The witnesses I've talked to, people, some of them have said, things just didn't look right all of a sudden. I had one witness tell me a couple of weeks ago, and I wrote about it in Dark Matter Monsters. She said the trees didn't look right all of a sudden. And then she got this feeling of panic. It's like something was just wrong, and this feeling of being watched, This is before she comes back and they find that their sweatshirt had been placed 12 feet high on a post when there were no other people or cars around, neatly placed at the top of they had to get on top of their car to get it down. So talking to these witnesses, I've talked to others who've talked about the battery and camera failure. Well, when you see this happening around coherent matter experiments, it's a fundamental property of ball lightning to do this, and people report going out looking for Sasquatch, but encountering balls of light. Even Les Stroud said this happened near Portland when he put that in his Survivorman Bigfoot series on YouTube, a bonus episode. He goes out to Portland. This woman has this forest. She said, I'm seeing Sasquatch out there. Les says they didn't see any Sasquatch. They encountered these balls of light, and then they heard voices talking in their heads. The orb phenomena and the balls of light are so intrinsically connected to Sasquatch and Bigfoot. And the phenomena that you see around Sasquatch, Bigfoot, and ball lightning and coherent matter is so similar. It just seems to me like the same phenomena. I'm not saying that Bigfoot is literally a ball of light. I think what's going on here is you're dealing with a fundamentally similar level of matter, where you have a type of life, a creature that has learned to interact with different frequencies of nature that we don't know how to do. Maybe we forgot how to do it, where the ball lightning emerges from. That it can actually tap into this as an energy form or either transform into a state where it's interacting with this coherent matter that gives it these properties that we see. The sense of time loss, time-space changes, the telepathy. That's very interesting because as someone who's been involved with remote viewing, there's a type of resonance where you get this instantaneous communication between distances. We all are used to this in terms of radio. But when we encounter it in a non-ordinary circumstance, it seems paranormal. But what we're talking about here is physics. To have a creature that could communicate with you telepathically. I heard of a case recently where the woman, I believe it's the Tennessee Smoky Mountains. The thing's knocking on her door. She's in her mind, she says, I'm going to get my rifle. And she hears a mechanical voice in her mind. She said it was like computer mechanical saying, don't bother to get your guns. They won't be any good against us. And she had just had the intention of going to the closet in the bedroom to get a rifle. And she realized at that point she was beat. They could anticipate her actions. That we're talking about a type of physics where there's communication. We're used to reality where things are separate. You're over there, I'm over here. Linear time, like we were talking about at the beginning of the interview, kind of linear sense, everything is measured and even. But that isn't the way nature works at the basis of reality. It works through resonance. And we're the ones that are cut off from that resonance in the way we live, because we're used to having the resonance done for us through technology. We all have very sophisticated microprocessor-driven technology in our phones, in our laptops. We all use this. We're all dependent on this. The internet. But let's say nature already had this built in, and there's life that knows how to tap into nature's internet through resonance. It would already be able to do all of this stuff that we think, we're so impressed with, and we're always going to buying the latest gadgets. I'm just like anyone else. But let's say this is already built into nature. It has to be built into nature or we wouldn't have technology to do it. That's what my dissertation was about right here at WSU. It was about maybe nature already knows how to do what technology does for us mechanistically.